I would guess, and I'm happy to come back and be proved wrong, but I think that this year, 2026, will be the second warmest year on record. May not quite make the warmest, but 2027, with that El Nino impact, we will be way beyond 1.5 degrees global warming because of that extra heat being put into the system.
Something in the Pacific is stirring.
Winds are changing, water's warming, the signs are here.
And it will shake the whole world.
Scientists call it El Nino.
But this one, it could be a monster. It's even been called Godzilla.
So, how worried should we be?
Welcome to The Climate Question from the BBC World Service. I'm Greg Jackson.
And I'm Jordan Dunbar.
To help us answer that, we have Mark Maslin, Professor of Earth System Sciences at University College London. Welcome back, Mark.
Brilliant. I'm very glad to be here.
Mark, just tell me, should this Godzilla El Nino be my new nightmare fuel? How worried should we be about it?
I think the important thing is that scientists are able to predict the coming of the next El Nino. And we know that it's going to be a big one, whether you call it a Godzilla or you call it super, as I do. It means that we can warn policymakers. It means that we can actually tell people this is the likely impacts. And I'll go through some of the impacts of a big El Nino. So firstly, droughts occur in East Africa, northern India, northeast Brazil, Australia, Indonesia. If we then shift to, say, heavy rains and floods, these occur in California, parts of South America, the Pacific, Sri Lanka, and the east central part of Africa. We also know that ENSO affects the strength and the paths of hurricanes and cyclones around the world. So we are pre-warned so we can start thinking about how do we protect people from these extreme weather events that result from this El Nino.
And Godzilla is a particularly evocative way to describe it. I think I would call it Ursula from The Little Mermaid, because having watched that recently, actually quite terrifying she is. But you would probably refrain from that kind of terminology, right?
So there's a balancing act in science, which is we have technical terms and some of them are really dull and some of them are not helpful at all. But we also need to communicate. This El Nino is going to be as big, if not bigger, than the one we had in 2016 and 1998. And they were really big ones. So we're seeing that's something that we haven't had before. This is beyond El Nino. This is a big one that's coming. Please be warned. Godzilla, okay, it makes nice sort of like headlines for the BBC or for the newspapers, but, it really isn't for me evocative of what is going to happen.
Mark, you mentioned ENSO there, which is the El Nino Southern Oscillation. What exactly is El Nino?
El Nino is part of an oscillation, the southern oscillation between El Nino and La Nina. And this is where the ocean currents and the actual winds of the Pacific Ocean shift. Now, we need to step back and think about the Pacific Ocean because people don't realize how large it is. Think about it. It takes about 12 hours minimum to fly across the Pacific, whereas it's about 5 to 6 to get across the Atlantic. So this is a huge body of water. And what happens usually is the winds blow from the east across to the west. These are the trade winds, and therefore it pushes the cold water from South America across the Pacific towards Australia, trapping the hot water around Australia and Southeast Asia. What happens during an El Nino event is those winds weaken, that warm pool spreads across the Pacific Ocean all the way to the coast of South America. Now, this changes the weather patterns around the world, it changes the jet stream, and this is where you have all these consequences from India to Africa to Indonesia, even into the southern USA.
Mark, you mentioned La Nina a couple of times. Is that just the opposite of El Nino?
So La Nina is literally the opposite. It is when the cold water from the eastern side of the Pacific really pushes the actual warm pool right against Southeast Asia and Australia, and it keeps that warm, moist air there, spreading that cold water across the Pacific. It has impacts which are El Nino-like, but in many cases opposite. And so therefore an extreme La Nina can sometimes be as destructive as a El Nino.
Now, Mark, you've said a couple of times that this El Nino is not only a super El Nino, but probably much bigger than the previous super El Ninos we've seen before. Why is that? Is climate change, is there a fingerprint here? Why is it so big?
So we have to be very careful. We know that climate change is heating up the ocean, but it's not doing it evenly. So there are certain places that are warming up quicker and some places that are staying relatively cool. And that changes the dynamics. We see that El Nino and La Nina seem to be more extreme over the last couple of decades. We think this might be due to climate change, but whether this particular El Nino is actually climate change caused or is it just part of that big cycle, we can't tell you. But what we can say is that El Nino has a real impact on global temperatures. So the last two big ones that we've talked about, 98 and 16, they added about 0.2 to 0.3 degrees Celsius to global temperatures. So for me, I would guess, and I'm happy to come back and be proved wrong, but I think that this year, 2026, will be the second warmest year on record. It may not quite make the warmest, but 2027, with that El Nino impact, we will be way beyond 1.5 degrees global warming because of that extra heat being put into the system.
But just to check, that is temporary, right? Because El Nino is a cyclical cycle. So it's not 0.2 or 0.3 degrees forever. It's for however long El Nino lasts.
Oh, absolutely. And this is why every so often climate deniers turn around and go, "Oh, look, climate change is over." Because what you get is you get this warming, you then get these peak warming periods, which seem to occur when you have El Nino events. And then the following year or 2 years, then there's a slight cooling. It isn't a cooling, it's just dropping back to the average, which is warming up every single year. So you get these sort of like going up, slight down, up again, slight down. Now, again, every time we have one of those downs, it's like, see, climate change is over. It's not happening. It's like, no, that's because you're just taking the last El Nino as your peak temperature.
I mean, lots of people will think not 0.2 degrees, that doesn't actually sound like much, but can you talk us through what the impacts and consequences have been in the past? Because the last one in 2016 caused trillions of dollars of damage and lost income.
Oh, and more importantly, it affected at least 60 million people. So yes, we should worry about the damage, but it's the impact on people. The one in 1998, we know killed 22,000 people. Let's have a look at the El Nino for 2016. It was one of the warmest ones on record, had severe impacts around the world, but let's pick on a few areas. So sub-Saharan Africa had failed rains that left 20 million people in southern Africa at risk of acute food shortages at the same time as they had catastrophic floods in East Africa. And many of you may remember those from Kenya. If we go to Latin America, the dry corridor in Central America suffered such a severe drought that millions of people needed food assistance. It also coincided with the record-breaking tropical cyclones, Cyclone Pam and Cyclone Wilson in Southeast Asia, which devastated local infrastructure. So there are real impacts. And the other impact, which is beyond humans, is that we know that every time you have one of these extreme El Ninos, you get coral bleaching. And the problem with coral bleaching is that once the coral's died, it doesn't come back quickly. So even though the El Nino may only be a year and a half in duration, it kills off the coral that can take decades, if ever, to come back.
Is it useful then to use El Nino or the super El Nino as a snapshot of what could happen if we continue to warm the Earth? Is it useful to look at the effects it have to then think of what would happen if we warm it even more?
Okay, so I'm going to give you that classic science answer, which is yes and no. So the yes, because it shows you what extreme climate change will look like. It shows you what extreme weather events, it shows you the disruption in particular areas. The no is that El Nino is a particular phenomenon. which is it changes the actual circulation of the atmosphere around the world. So this is why places get drier and they get wetter. Now, this is not necessarily what's going to happen with climate change in the exact geographical regions, because this is a Pacific driven engine of heat and moisture, which is changing. So the El Nino is a particular thing that we need to worry about and understand, but it does give us an idea of what extreme weather events will be happening in the next decade because of climate change, but they won't be identical.
So this isn't the same as what we're going to see with climate change in the future.
No, so El Nino does a particular changes around the world, which we've discussed in this program. And that is a unique feature of the heat and moisture engine in the Pacific Ocean changing, which then shifts that all around the tropics and the subtropics. Whereas climate change impacts the whole world and changes it in different ways. So the geographical impact of El Nino will not be the same as climate change, but it's indicative of those huge changes and impacts of extreme weather we're going to see, and we're already seeing with climate change, and we'll see in the next decade or two.
The heating in the Pacific is causing these global impacts. We're talking about wildfires, droughts, flooding. Is that what is causing the majority of those deaths that you talked about previously?
For me, one of the biggest problems is food security. The reason being is that at least half our food is produced by small holder farmers. Okay, so these are people that have people that work outside for them, and there are certain times of the year when it's too hot and too humid to work outside. Now, climate change is already making that more common. And when we have this super El Nino, that increase in temperature is going to cause that to increase. But then you have the extreme weather on top of that. That's going to disrupt food production through flooding, through droughts, through heat waves, which means there's not enough food in those countries. And that's where you had, in previous El Nino, real suffering because of a lack of access to food or access to affordable food. There's also the direct effects of extreme weather events. We know that floods, droughts, heat waves can directly impact people through loss of life, but also real impacts on well-being. Again, lots of people suffer from long-term illnesses. Interestingly enough, for disease, droughts are the worst, because when you have stagnant pools of water that are slowly drying up, that is a breeding ground for a lot of nasty diseases. So this is the impact. But we know this is coming, so we can, if we are sensible, help those countries plan for the worst case scenario, which is likely to happen in the next 6 to 12 months.
What can governments on the one hand and then ordinary people do then when we have a prediction like not just an El Nino, but a super El Nino?
So I think it's really important that governments take on the science and see where it's going to affect. So for example, if you're in Western Europe, El Nino is going to have very little impact, okay? Whereas if you happen to be a nation in East Africa, you know that this is going to cause flooding. If you're in sub-Saharan Africa, you know that there's going to be increased drought. So you can start to think, okay, the scientists have given me a head start. What can we do to minimize? You're never going to get rid of the impacts, but how can we minimize it? Do I store more food? Do I actually make sure there's shelters? What do I do? And there's some really good examples around the world where countries have taken on the science. So for example, Bangladesh. Bangladesh in the 1970s used to lose hundreds of thousands of people. These are deaths from cyclones. And what they did was they built their own meteorological office. They then started to predict when the cyclones were going to hit. They also then made sure that people were warned. They did it by radio, and they also did it by bicycles. So therefore, if a village heard about it on a radio, they would then cycle to the next village. Have you heard? Transmitting that knowledge. Because when people are pre-warned, you can prepare. They also set up things like shelters for people. They set up floating agriculture. And the deaths from cyclones have dropped to, if you're unlucky in a year, maybe 1,000 people, but a lot less most years.
It's really remarkable what Bangladesh has done, hasn't it? I think a lot of people will be surprised at how much just a few fractions of a degree, 0.2, 0.3, 0.4 maybe even this year, and how much of a big but also global effect it can have on people. And I'm wondering, you know, what would it mean if we got a whole degree or degree and a half of warming, which we're potentially projected to be on?
So the Intergovernmental Panel on Climate Change produced a really interesting report in 2018 called Global Warming 1.5. And what they were looking at is what would happen if we went over 1.5. And the most interesting thing is that between 1.5 and 2 degrees, there are a lot of systems that start to be really impacted. Coastal areas, coral reefs, agriculture all start to have a significant impact because the thing is not linear. You don't add 0.1 degree to the temperature and you get a 1% change. No, it's non-linear. So the warmer it gets, the bigger the impacts, much bigger than you would expect just from a small increase. It also showed that we really have to make sure we don't go anywhere above 2 degrees, because after that, we then have really severe impacts. We have the idea that the Greenland and Antarctic western ice sheet have gone by the middle of next century. And we're also looking at sea level rise that we can't cope with. We're looking at food disruption, and we're also looking at, and I know you've done programs on this, tipping points in the climate system, which could be triggered between 1.5 and 2, but some of the big ones are definitely triggered after 2 degrees.
Mark, thank you so much for your time today. I appreciate it.
Absolute pleasure. It's always great to be with you too.
And thank you for watching. Do give us a like so we know to make more shows like this. And if you have a climate question of your own, do comment it below and we'll try and get to it in a future show.
Don't forget, you can subscribe to the BBC World Service YouTube channel so you don't miss a thing. I'm Jordan Dunbar.
And I'm Gray Jackson, and from both of us, goodbye.